So in the previous section, in section 3.1, you learned the basics of calculating a probability, which is taking the number of outcomes for the event that you want to look at and dividing that by a total number of outcomes. So, one of the things that we learned in section 3.1 is that it's very important to be able to count the number of possible outcomes. Now, in some cases, like most of what we saw in 3.1, this can be done pretty simply by either looking at a small sample space, maybe using the fundamental counting principle, or just adding up the frequencies and getting a total frequency to use. In other situations, this is a little bit more difficult because we have experiments where there are incredibly large numbers of possible outcomes. So we're talking, hundreds of thousands, millions. And so we have to have some other methods that we can use just to quickly count the number of possible outcomes. And that's what we're going to be looking at in section 3.4. These are called counting principles. Now, we're going to talk about two different types, permutations and combinations. And we're going to start by looking at the different possible permutations. So the first thing I want you to note is that when you hear the word permutation, you are always dealing with an ordered arrangement of objects. So if you have a situation where you're not interested in counting the number of arrangements that you can have, where you're not counting possible orders, these are not the rules that you're going to use. But if you do have situations where you're looking at an ordered arrangement, like arranging people in line, ranking items first, second, third, fourth, fifth, looking at the arrangements of houses on a street, those are all situations where you can use your permutation rules to count the number of outcomes. So we're going to start with the most basic rule. The most basic rule here says you can count the number of different permutations, and remember that's just the number of different ordered arrangements for n objects. So n represents the number of objects that you have. And you can count the number of different ordered arrangements by calculating something called n factorial. Now, n factorial is just a product where you take the value of n and you multiply every integer from n down to 1. Okay, so for example, let's say that we wanted to evaluate 6 factorial. We would start with 6, and then we would multiply every integer, every whole number, from 6 down to 1, and we would have 720 as the value for 6 factorial. Now again, what that's telling me is the number of different ordered arrangements for 6 objects. So let's say we had 6 people and we wanted to know the number of different ways that we could arrange 6 people in a line. All right, that's an ordered arrangement. This rule says if we take 6 factorial, that will tell us there are 720 different ways to do this. All right, so let's look at our first example. All right, look at another situation where this rule would be applied. So in our first example here, we're looking at 8 people competing in a downhill ski race. And we are asked in how many different orders can the skiers finish, right? That's first, second, third, fourth, fifth, and so on. So the first thing I want to note is, okay, this is a situation where I am counting ordered arrangements. You got to make sure that's what you're looking at here. And thus, a permutation rule will apply. The other thing that I want to note is that I'm looking at a permutation for 8 total objects because I have 8 people competing in a downhill ski race. So that means n here is equal to 8. That's my total number of objects. And thus, the number of possible permutations can be found by taking 8 factorial. And again, that's a product. We start with 8 and we multiply every integer, all the way down to 1. And we get a value. Again, these are going to be very large values that we're talking about here. Factorials get really big really fast. of 40,320. Now, I also want to take a minute to note for you here that you should have a factorial key on your calculator. Or a factorial function somewhere in there. So because these numbers can get very big very quickly, a lot of times it's helpful to use your calculator to evaluate the factorial. So I want you to take a minute and look at your calculator, because I know, we all have different types of calculators. If you have the TI-83 or the TI-84, then what you're going to do is you're going to look for a math key on your calculator, and then under the math menu, you're going to have to go over to the right to a probability submenu, and in there you should see the factorial symbol, the exclamation point. All right, if you have a scientific calculator, then you could just have a factorial button, just looks like that. You could have a button that looks like X or N factorial, or you may have to go under like a probability menu and then look for it there. All right, if you can't find your factorial function on your calculator, send me an email. Just take a picture of your calculator, send me an email, and I will let you know where that is, because that will be helpful down the road to not have to always work out the entire product. All right, so anytime I want to look at the number of ordered arrangements for n total objects, all I have to do is take n factorial. All right, now in some situations, I'm going to skip down to this one at the bottom here. In some situations, we want to look at the number of different ordered arrangements, but not for n total objects. Sometimes we just want to look at ordered arrangements for a subset of objects. All right, and this is called taking permutations for n objects, but taking them by smaller groups. We call this groups of R at a time. So basically here, n still represents the total number of objects, but R represents the number of objects that we want to arrange in order. So for example, the 8 skiers that we just talked about, instead of looking at the total number of ways the 8 skiers can finish, maybe we just want to look at the number of ways the skiers can finish first, second, and third, right? That's 8 skiers, but we only want to order 3 of them, first, second, third. Those situations will always require the use of the NPR function. That's the notation that you're seeing right here. All right, so again, let's start by looking at an example of where this would be needed. In our second example, we have a list of 8 activities. And the question here is, how many ways can the subject pick a first, second, and a third activity? So again, the first thing I want to do here is I want to make sure that this is an ordered arrangement, right? First, second, third, pretty obvious it is. And thus, a permutation rule will apply. All right, now the next thing I want to note though is that I have 8 total objects, but this is not like my previous example where I want to order all 8 of them, right? I want to look at 3 first, second, and third objects to arrange in order. So when I see that, I say, okay, I've got 8 total, that's my N, but I have an R here, which is just 3, because I only want to order 3. And thus, I'm going to need to use my NPR function. Now, this is what the notation looks like. All right, you do a big P for permutation. N goes on the left-hand side, R goes on the right-hand side. Okay, so that's how you read this. You'll see it notated like that in the homework. Now, there's a couple of ways you can evaluate this, right? There is a formula. You see it right here. And if I want to use the formula, I'm going to start with n factorial. Remember, n is 8. And basically, I'm just dividing out what I don't want. N minus r factorial. See that in your formula here? And that will simplify to 8 factorial divided by 5 factorial. All right, and now hopefully you found that factorial key on your calculator, because that will make this much simpler. Rather than you having to work everything out, you can just go to your calculator find your factorial. And type it in exactly as it is here. So 8 factorial divide by 5 factorial. I'm typing exactly this into my calculator. And when I hit enter to evaluate, that will tell me there are 336 different possibilities for ranking the 8 objects first, second, and third. Now again, this is a good place to play with your calculator, all right, because you should be able to locate this NPR function in your calculator as well. All right, now like I said, if you got a graphing calculator, you should find it under the math and probability menu. If you have a scientific calculator, then you may just see the NPR button somewhere on there, or you may have to go under some type of probability menu. Wherever you found the factorial though, you should find the NPR function right there too. Okay, and so the other option here, and this will save you a lot of time, would be to say, okay, I'm going to go to my calculator and I'm just going to type in 8. I'm going to go get the NPR function, and I'm going to type in R. Remember, if you're going straight to your calculator, you want to type in the N and the R, just like that. And if you evaluate that in your calculator, you'll get that same number, which is 336 possibilities. All right, now in the Learn assignment for section 3.4, I also put a PDF document in there where I have some screenshots of making sure that you use the calculator properly. Again, these are for the graphing calculator. But if you have any questions about using your calculator for these, and please reach out to me and let me help you through that. Because when you're doing the homework, and I'll go ahead and kind of caution you on this in 3.4, if you go to the help tools, it's going to walk you through the long process. All right, so for example here, it would have you evaluate 8 times 7 times 6 times 5 all the way down. And then it's going to have all this over 5 factorial. All right, it's probably going to start simplifying like this. And it gets to the same place, but it can take a lot more time, especially depending on the formula that you're using. So I would encourage you to find these functions on your calculator. That way, all you have to do is focus on, okay, which one am I using? Factorial or NPR? What is N? What is R? And then you just go to your calculator, type it in, and let it do that portion of the work. All right, so let's look at one more here. I want you guys to look at this one first. I'm going to give you a minute to think about it. You have a club with 38 members, and you're wanting to select 4 offices: president, vice president, treasurer, and secretary. Now, I'm going to go ahead and just give you a heads up here. This may not seem like an ordered arrangement because it doesn't state order and it doesn't state a first, second, and third. But I want you to note that these are ranked offices, right? Which means the order is important. So just to give you a heads up here, anytime you're looking at ranked offices, that is another example of an ordered arrangement, and thus a permutation rule will apply. So when you think about the 2 rules we've defined so far, the factorial and the NPR, think about which one you would want to use here, and then see if you can use your calculator to correctly evaluate the number of different possibilities. All right, so I want you to notice how I worked through that. The first thing I did was I made sure, yes, this is an ordered arrangement. It's a permutation. And then I looked to see my total number of objects. I had 38 total members. Now, if I had wanted to order all 38 of them, first through 38th place, that would have just been a factorial, a huge number. However, because I wanted to order 4 people, I wanted to place them into 4 ranked offices, that gave me an R value, a subset, and thus I needed to use my NPR function. All right, and again, I went to my calculator for this, which is what I encourage you guys to do too. All right, so locate that function on your calculator, practice using it, and in this case, you should get a very large number, because you're starting with a big value of n, of 1,771,560 different possibilities. Okay, now we have a third situation using a permutation rule. All right, and I want to start with the example here just to show you where this is needed, and then we'll go back and look at the rule and the formula and what it looks like. All right, so if I just read through this next example, I'm looking at developing a subdivision. And I am given information about 3 different types of objects. I got 1-story, 2-story, and split level. All right, now the question here, it says how many ways, distinguishable ways, can the houses be arranged? So first thing I'm going to do is say, okay, this is an ordered arrangement. Thus, the permutation rule will apply. All right. Now, if I'm going to use a permutation rule, I always have to know my total number of objects. So the next thing I'm going to do is say what I'm arranging here, 6 and 4 and 2, I have 12 total houses to arrange. Now, you know, when I'm choosing between the factorial and the NPR, right, what I want to think about is, do I want to arrange all of them, or do I just want to arrange some? And in this case, right, there's nothing in here that tells me I'm only going to arrange 5 of them. It says, in how many ways can the houses, all of them, be arranged? So that would tell me that I need to use the n factorial. All right, so I'm going to come over here and I'm going to start with that. The number of different ordered arrangements, permutations, for all 12 houses would be 12 factorial. Now, the thing that makes this one a little bit different is that we have objects that look the same, that are of the same type, or sometimes we see these as repeating objects. And when that happens, what I want to do is I want to make a note of it by labeling each one as a subgroup of n. So like for n1, I'm going to say, all right, we've got 6 objects, which are all the same type, because they are 1-story houses. All right, now I have another group, so I'm going to do an n2. We have 4 objects that are alike, because they're all 2-story houses. And then I got one more group, I'm going to do an n3. We have 2 objects that are the same, because they're both split level. All right, this is why the question says, in how many distinguishable ways? Distinguishable means they look different. And if you don't account for these objects that look the same, then you're going to be double and triple counting ordered arrangements that don't look any different, where maybe you just took 2 1-story houses and flipped them, but it doesn't look any different. It's not distinguishable. And when that happens, what you have to do is you have to divide out those subgroups. So I'm going to start with the total, the 12 factorial, but I'm going to take the factorial on each of these subgroups, and I'm going to divide it all out. Okay, now again, use your calculator here, use your factorial key, and make sure to put your denominator in parentheses. All right, but if you do that, you can evaluate this all using your calculator. I'm going to do 12 factorial divided by, and then I'm going to open parentheses and do 6 factorial. Now, on a scientific calculator, you may need a little multiplication symbol in between. On a graphing calculator, you shouldn't. All right, but I'm going to divide by 6 factorial times 4 factorial times 2 factorial. And again, make sure these are in parentheses or it won't evaluate correctly. And when I hit enter, that's going to take out all the ones that look the same, that are not distinguishable, and tell me I've got 13,860 possibilities. Okay, now again, use your calculator for the evaluation. If you go to the help tools for these problems, it's going to show you how to get to this formula up here, but then it's going to start writing everything out. You don't need to do that. Use the factorial in your calculator to evaluate. That way your focus is knowing when to use what rule and knowing what your values of n and r need to be, and then letting your calculator do the evaluation. All right, this is the formula that you're seeing in the middle back here for distinguishable permutations. All right, and this is needed anytime you have objects that are the same, all right, like the same type of house, the same type of tree, the same blood type, right? Objects that are the same, or you could word this as objects that repeat. So let's say maybe you were arranging the letters in a word, but you had letters that repeated. Those again would be your little subgroups of n. So you're going to see different examples of this as you go through the homework. Okay, now I mentioned to you at the beginning we were going to talk about permutations and combinations. So permutations are ordered arrangements, and you have 3 different cases to look for. If you're looking at a situation where you are not interested in order, right, where you just want to take a selection, you just want to form a group, but you are not interested in any type of arrangement of the objects, then you use a combination, all right? You use an NCR function instead, because there will be a less number of possible outcomes. All right, so in our last example here, we need to select 4 groups from a group of 20. And the question here says how many different groups of 4 subjects are possible. So again, the first thing you should note here is, okay, I'm forming groups. I'm not ranking them. There's no ranked offices. I'm not ordering. I'm not arranging in any way. So this is a situation where I'm not looking at an ordered arrangement. Thus, I'm going to use the combination rather than the permutation. Now, n and r work the same way. It's just in this case, n would still be your total number of objects. We have 20 subjects to choose from. And r, since we're not ordering, represents the number of objects that you want to select for your group. In this case, we need 4 subjects. So we're going to say, okay, we need to use a combination because we're not arranging in order. We have 20 total, and we're going to choose them 4 at a time. Now again, you have a formula up here that you can use, and that's what the help tools will show you. But you should also have an NCR function in your calculator. Same place you found the others. And so in that case, you can just type in 20, NCR, and 4. And when you hit enter to evaluate that, 20, NCR 4, that's going to tell you there are 4,845 different possible groups. Okay, so the first thing you need to do in 3-4 is you need to get comfortable with identifying when to use a rule and making sure you use it correctly. So what I want you to do at this point is take a break from the videos and go to your homework, go to your practice problems, and look at problems all the way up to 15. It's going to have you just using the counting rules and give you different types of situations where you're asked how many possibilities are there. And once you feel pretty good with the counting rules and you're using them correctly, then I want you to come back and watch my second video where we're going to be using the counting rules, the number of outcomes, and applying them to our basic probability rule, which is the event divided by the total.